Sklearndecompositionfastica. Description: explain in detail. Fast ICA is an algorithm for independent component analysis. ICA is a statistical method for separating a multivariate signal into a set of independent components. It is based on the idea that the observed data is a linear combination of underlying independent sources. The goal of ICA is to recover the original sources from the observed data. Inputs. Input 1. Explain in detail. The input data must be a 2D array, where each row represents a sample and each column represents a feature. The data should be centered, zero mean, and preferably whitened. Input 2. Explain in detail the number of independent components to extract. This is also known as the number of sources. Outputs. Output 1. Explain in detail the estimated independent components. This is a 2D array, where each row represents an independent component and each column represents a sample. Output 2. Explain in detail the mixing matrix. This is a 2D array that represents the linear transformation that was applied to the independent components to generate the observed data. Steps. Step 1. Explain in detail. The fast ICA algorithm begins by whitening the input data. Whitening ensures that the data has zero mean and unit variance. This helps to improve the performance of the algorithm. Step 2. Explain in detail. The algorithm then iteratively searches for directions in the data that are maximally non-Gaussian. This is done by using a contrast function that measures the non-Gaussianity of a given direction. The contrast function is maximized by finding the direction that has the highest kurtosis. The kurtosis is a statistical measure of the peakedness of a distribution. A distribution with a high kurtosis is more peaked than a distribution with a low kurtosis. Metrics. Metric 1. Explain in detail the kurtosis of the estimated independent components. A higher kurtosis indicates a more peaked distribution, which is a sign of non-Gaussianity. Metric 2. Explain in detail the mutual information between the estimated independent components. A lower mutual information indicates that the components are more independent. Visualization plots. Visualization plot 1. Explain in detail a scatter plot of the estimated independent components. This can be used to visualize the relationships between the different components. Visualization plot 2. Explain in detail a histogram of the estimated independent components. This can be used to visualize the distribution of each component. Fine-tune parameters. Parameter 1. Explain in detail the algorithm. Parameter n components is used to specify the number of independent components to extract. Parameter 2. Explain in detail the algorithm. Parameter algorithm specifies the algorithm to use for the optimization step. The options are parallel and deflation. The parallel algorithm is faster but may not converge as well. The deflation algorithm is slower but is more likely to converge. Uncertainty methods. Uncertainty method 1. Explain in detail one way to assess the uncertainty in the estimated independent components is to perform multiple runs of the fast ICA algorithm with different random seeds. The variability in the estimated components across different runs can be used to estimate a uncertainty. Uncertainty method 2. Explain in detail another way to assess the uncertainty is to use bootstrapping. Bootstrapping involves randomly sampling with replacement from the original data. The fast ICA algorithm can be applied to each bootstrap sample, and the results can be used to estimate the uncertainty. Challenges and fixes. Challenge 1. Explain in detail the fast ICA algorithm may not converge if the data is highly correlated. Sample use case that resulted in challenge 1. If the input data is highly correlated, then the fast ICA algorithm may not be able to find independent components. This is because the algorithm relies on the assumption that the data is a linear combination of independent sources. If the sources are highly correlated, then the algorithm may not be able to distinguish between them. Fixes to challenge one way to address this problem is to pre-process the data by using a method such as principal component analysis (PCA) to reduce the dimensionality of the data and remove correlation between the features. Another option is to use a different ICA algorithm that is more robust to correlated data. Challenge 2. Explain in detail. The fast ICA algorithm may be sensitive to the choice of a contrast function. Sample use case that resulted in challenge 2. The fast ICA algorithm relies on a contrast function to measure the non-Gaussianity of a given direction. The choice of the contrast function can affect the performance of the algorithm. For example, if the contrast function is not well suited for the data, then the algorithm may not converge or it may produce inaccurate results. Fixes to challenge 2. One way to address this problem is to try different contrast functions and compare their performance on the data. Another option is to use a different ICA algorithm that uses a different contrast function.